Okay, so this is going to be a presentation about database theory. I'm going to talk about entities and attributes and how they map to tables and fields. We're also going to talk about relationships, including primary and foreign keys, data redundancy, and referential integrity. So entities are real-world objects or things that we want to hold information about. So we might see a group of people as customers, employees, or even patients. We can hold information about vegetables, books, or holidays. Once we've identified our entities, the next thing we have to consider is what information we're going to hold about them, and this is stored in the attributes. So if we're going to sell vegetables, we might decide to hold information about the price, about the supplier, about the quantity we hold in stock. Alternatively, we might be more interested in the nutritional value of vegetables, so we might want to store details about the vitamins and the minerals that it contains, perhaps the best cooking method or the fibre content. The choice of attributes would depend on the purpose of the database, particularly the reports you might want to run against it. In a real-world scenario, this information would come from the client who's actually commissioned the database. When we come to define our tables, the entity becomes the table, in this case products. The attributes become the fields, and we want to store the same information about each of the products. So we want to store the product code, the description, the supplier code, the price, the quantity in stock. And then we can also set each of these to have a data type. So the product code might be text, the description would be text, the supplier code could be a number, could be text, depends on the system that's in use. The price would be currency, and the quantity in stock would be number. Here we can see what it looks like when we turn that table design into an actual table. You can see the different records that we've stored. So we're storing information about potatoes, carrots, and cabbage. Sometimes when you're designing database tables, it can be helpful to actually plan it out in this way so that you could see the data that's going to be held in each field. One field in a table must hold a value that is unique for each record. It's quite common to have two customers with the same name, but if you were to actually mix up those customer records, it could put your company in breach of the Data Protection Act. So a primary key helps us remove any possibility of confusion. It can be very tempting to hold all the information you need about one product in one table. For example, here you can see that we're holding supplier information, including the supplier code, supplier name, the address, the town and the postcode. All of this information is vitally important, and it makes sense to put it all together. Except that because we get more than one product from a particular supplier, we're actually duplicating a lot of the information. We're holding the name over and over again. We're holding the address over and over again. And this can actually be quite inefficient. It can take up extra storage space that's just not needed. But also, it can make things very inefficient when you come to actually do any updates, say if the supplier changed their address. It's much more efficient to take the supplier details out and put them in their own table. That way, the product code stays as the primary key for the product table, but then the supplier code becomes the primary key for the supplier table. This is one of the first steps in the process that we call normalization. And normalization is the idea of analyzing data to make it more streamlined and more efficient to store. Of course, we don't have to hold a record in the supplier table for every record that we hold in the product table. We only have to hold a single record for each of our suppliers. And then we can use that primary key within our product table. This time it becomes a foreign key, so that we can look along and see that product P002, which is carrot, is actually supplied by the supplier S001. We then go to the supplier table and look up S001 and see that it's the supplier Smiths. The relationship between these entities can be represented in an entity relationship diagram. In this case, we can actually see how the two boxes, suppliers and products, are linked by what I call a crow's foot. And that shows that a supplier can provide many products but each product is provided by only one supplier. Whenever we talk about the relationships between database tables, we must consider referential integrity. The idea here is that every foreign key must be linked to a primary key, and this comes into play whenever we insert, update, or delete a record. As you can see in this example, if we look at the product table, that's the one coloured blue, we've tried to enter a record for the product code P007, which is broccoli. But we've said that the supplier code for this particular product is S003. But as you can see from the green supplier table, there is no record starting S003 as a supplier code. And it just doesn't make sense to try and enter a product for a supplier that doesn't exist. And this would actually be a breach of referential integrity. The idea here is that we should enter the corresponding supplier code first in the supplier table, and then after that we can enter the corresponding product codes. Referential integrity can also be affected when you update a record. In this case, if you actually try and change the primary key where there's a foreign key in another table, this would actually break referential integrity. In this example, we've changed the code S002 in the actual supplier table to be SUP02, and as you can see in the two areas that are highlighted red, these no longer match, and therefore the link between them is broken. Similarly, when we delete a record, we can actually break referential integrity. In this example, you can see that the products P004, P005, and P006 all come from the same supplier, the supplier with the code S002. The difficulty there is that we've deleted the corresponding record for the supplier S002, and therefore the link between the tables is broken for these records. Some software applications, such as Microsoft Access, allow cascade delete. This basically means that if you delete a supplier from the supplier table, all products provided by that supplier are also deleted automatically. Now this maintains referential integrity, which in itself is a good thing because it keeps everything straight in the database, but some records, particularly financial ones, records of sales and such like, are actually required to be kept by law. An alternative to deleting records is to actually use a flag on a record to indicate if the record is current or not. This can be done in something like Microsoft Access by using a Boolean value, which is either yes or no, true or false. And the idea with this is that you can set certain records to be true or false, and then a filter can be applied so that in this case only products will be displayed for suppliers that are currently in use, where the flag is set to true.